prayer. Let us always remember that we are in the most holy presence of the Lord. For Catholic brethren, that the our heads and the sign of our faith, in the name of the Father, and of the Son, and of the Holy Spirit. Amen. Father God, praise and thank you for your gift of life. Thank you, Lord, for this day. Thank you, Lord, for this time that we're able to gather together to have this event. Oh Lord, continue to bless, guide, and protect each and every one of us. Guide us in the things that we do, so that we will be able to give you glory. All these things we ask and pray in the mighty name of Jesus. Amen. O Sacred Heart of Jesus, have mercy on us. Holy Mary, Mother of God, pray for us. Saint Ignatius of Loyola, pray for us. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. So, Magis morning to everyone. Usually here in Sacred Heart School, Ateneo de Cebu, we greet each other Magis morning. Magis is the way of saying to do more and be more. Yes, please try to come over. Please have a seat. You can register there later on. So again, we're just starting up. So thank you very much for joining us in this event. And we hope that each and everyone will be able to get to know more about trends in robotics and also especially in the field of education from kinder to grade 12. So I know that you guys are very much excited. So without further ado, I'd like to present our president of CSTA Philippines, Mamta. This time.
Yan. Good morning. Can you guys hear me okay?
Yeah.
All right, very good. I can see Team DEVCON over there. Yay! And Team Sacred Heart. Ateneo de Cebu. And of course, to all the teachers that are here present joining us, including those who are online. Welcome, welcome, welcome. So as Sir Mike had mentioned earlier, this is our first event post-pandemic. It's our very first face-to-face event, but this is even a hybrid event now. But even then, this is our first event with a face-to-face component ever since CSTA Philippines was founded in 2020, right during the pandemic. So welcome everybody. Thank you for being here. So my job to you this morning is to introduce Computer Science Teachers Association and also to introduce the Philippine chapter of the Computer Science Teachers Association, followed by an introduction to our speaker, Mr. Tom Lauwers from BirdBrain Technology, who has some really fantastic presentation in store for all of us. So he is scheduled to come in another about 10 minutes more. So I have at least that much to go through some things with you. All right, so CSTA Philippines, as you can see on the screen, you know, that's what we want to do. We want to be the voice of equitable access to enable computer science education teachers, computer science teachers to deliver a world-class K-12 computer science education. And we do this by establishing a community, a computer science community, a local one. Also, we build to connect everyone with each other. Also, we want to be together to create and provide for professional development, to help you improve in your teaching. And lastly, but not the least, we want to connect the local voice. In this case, it could be Cebu, it could be Philippines, to the bigger audience of the world of teachers doing computer science. So that's kind of where we situate ourselves. So as a new organization, we do have a website and we do have a Facebook page and we have our Twitter page. So I want to show you our website. It looks like this. Okay, let me make this bigger. So this is CSTA Philippines. And because we are a chapter of the US-based one, we get everything from the US as well. And this is our event today. So if we had other events, it would show here. And of course, we have news on our website as well. And you can join CSTA Philippines from this page. So that's that. So how to join CSTA Philippines? Because we want you to join us. We want us to help each other. And so you go to this web page and then you create your account, and it's for free. Or you can also do the CSTA Plus membership that gets you a little bit more, but that's of course comes with the cost. But the basic membership gets you a lot. So that should be a great start for anyone, any teacher. Please go ahead and start. We invite you to join us. And then once you have your account, you can log in, and then you can find the Philippine chapter to associate yourself with our chapter. You can also live without, joining any chapter, but it's better when you are together with your own friends, I think. So the Philippines was the first non-North American chapter ever created, non-US based so non-North American based. So there have been chapters in Canada, but for a long while, we were the first non-American chapter. So we're very proud of that. We're very proud of that. And I told you before, we were established in 2020. And we have 6 officers on the board. And we have elections every 2 years. So we just had elections last month. And these are our officers. We have Miss Jess as our vice president, Mr. Edwin de Guzman as our vice president for communications, and Mr. Joel Bautista, who is joining us online, as our secretary, chapter secretary. And of course, your Mr. Michael David John Abelio. He is our chapter treasurer. And our immediate past president is Mr. Edge Angeles. So yeah, you can be one of us anytime soon. Please join us. So I was telling you that the local CSTA is a chapter of the US-based Computer Science Teachers Association. So that organization, I just want to briefly tell you about, is an organization that understands that teaching computer science is not easy, it's hard. So that this dedicated group of teacher-led board of directors focus on creating a strong environment to support our K-12 education. So let me show you. This is where we show up, not that one. So this is the whole organization, the Computer Science Teachers Association calendar. And we have an event today, and that shows up right here. So everybody in the whole world can see and learn that we are having this event. And members like Dr. Juan Pinto, who's joining us from Los Angeles, actually can join us. So it's open to all members. The same for you guys. You can also take advantage of the events for us in all over the world. So you just go to events and then look for those things that are interesting to you that you can use in your practice. So, isn't that interesting? We are part of a bigger and larger organization. In fact, they always say that when you become part of the Computer Science Teacher Association, you become part of the world's largest computer science department. And it's true. It's really exciting when we come together for our conferences. So you can look forward to that as well. Computer Science Teachers Association, you're welcome to check out the website, of course, but they are a voice for teachers. So values, these are some of their values. They are a voice for teachers and driven by teachers. So often, that's the basic grid. Their kind of line, is it still for teachers, or are we now serving other people? And if so, then we won't take particular actions, because we want it to be only for teachers and should be driven by teachers. So CSTA believes that teachers are essential to ensuring that all children receive a high quality computer science education. So this is all we are. So CSTA also is member focused, and that CSTA builds CSTA builds strong member relationships so that we value each other's input, and we can act on our freedom, and we recognize our contributions to the community. Second to the last, CSTA is committed to equity in our community and for the students our members serve. So that just means diversity in abilities, and diversity in all other ways. So we welcome all computer science educators and supporters to help build and grow community. And lastly, exactly, CSTA is a place to grow. Personally, I have grown so much in my association with the CSTA since 2018. I just joined it in 2018, and yet I have grown and learned so much about how to lead, and not just lead, but also be a computer science teacher in a K-12 setting. So join us. Hopefully I can get you to join us. And of course, we join international events like I was showing you earlier. The next one coming up soon is our annual conference, and that usually is a 3-day in-person event. But the board has decided, because it needed to reach many of us who are not able to travel to the United States or not in the United States to attend the conference, they decided that every other year would be a virtual conference. So teachers like us who are not in the US can still participate. So this year it is virtual. It'll be on Hop-In on July 11 to 13. So the early bird registration ends on May 31. If you can get your schools to pay for you to go, or if you were an officer at CSTA, you could get to go for free. So strive to join us, please. All right, so what is the CSTA conference? So it's a chance for computer science teachers to come together, find strength in their local community through networking events, engaging in professional development that you really want to attend, and also identify ways to impact students and teachers outside your classroom. So the 3-day virtual conference has over 150 sessions of education to broaden your knowledge. So 150 breakout sessions, including very engaging keynote speakers. For example, this one really got to me. It says, how to teach computing, how to teach computing. And it said research-backed pedagogical practices to support student learning. So that's just one of those. And again, the CSTA National Conference is on July 11 to 13. It is virtual this year, and you are welcome to join it. On the local scene for the Philippines, we are having our first purely face-to-face meeting on July 13th, 2023. Forward, please. 2023, July 13, our very first face-to-face meeting, which you are all welcome to join us. Save the date. All right. And thank you. I want to thank some folks, really important. First of all, our DEVCON Kids team who has brought our robots. Thank you for your time and your talents. And of course, Miss Robin, if you're there, raise your hand. Miss Robin, did she make it? Is she come? She's coming. Miss Robin is coming. She's coming to join the DEVCON Kids team. And of course, the Sacred Heart School, our host, Ateneo de Cebu. Thank you so much. And Bo's Coffee is providing us with coffee today. Thank you to Bo's Coffee. And here we go. Sir Michael. Thank you so much for Sir Michael. Yes, he's done so much organizing on the ground and to all of you who supported Sir Michael to get this together, I applaud you and I'm really thankful. Okay, so let's see if Tom has arrived. And
Yep,
he's
I'm here.
All right. Thank you, Tom. Okay, let me do some kind of introduction for you.
Okay.
Okay. Oops, not that way. All right. So, Tom Lauwers. Did I say that right, Tom? Let me see. Okay. So, Tom is the founder and CEO of BirdBrain Technologies, and he is based out of Pittsburgh, Pennsylvania. Correct so far, Tom?
Yep, that's all right. About 12 hours different from where you all are.
Exactly 12 hours from Cebu. Yes. So Tom has completed his BS Electrical Engineering and Public Policy and a PhD in robotics from Carnegie Mellon University. Tama, is that right?
Yep, that's all correct.
Okay. Tom leads groups of educators, engineers, and researchers to create new educational hardware through thoughtful listening-based design process. So through a thoughtful listening-based design process. As a founder and CEO of BirdBrain Technologies, Tom has a 12 plus years experience in scaling and iterating the products created by this design process while running a bootstrapped, I know about that, sustainable and profitable business. BirdBrain's products like the finch, which you will see in our playground today, the hummingbird and the owlet have collectively been used by approximately 1 million students to learn coding, engineering, design, and STEAM. Oh my gosh, that's incredible, Tom.
It's hard to believe. Yeah.
BirdBrain's Technologies mission is to inspire deep and joyful hands-on learning in all students. Deep and joyful hands-on learning. So BirdBrain Technologies cultivates creativity and makes abstract concepts hands-on by providing flexible and inspiring classroom tools like the Finch robot, the Hummingbird robotics kit, and the new Owlet math collection. So founded in 2010 at Carnegie Mellon, and it is a research-based company, like we said, that promotes gender equality and diversity in STEM with a focus on computer science, engineering, math, and robotics. So really right on the spot where we need to be today. And last but not the least, Tom is going on a 140-mile bike ride to raise funds for multiple sclerosis next week. You know how many
about that? Wow.
I was on your LinkedIn.
Yeah, that's true. Yeah.
225 kilometers, guys. 225 kilometers bike ride. That's long. I salute you, Tom, and welcome to CSTA Philippines, and welcome to our event today.
Well, thank you so much for the invitation and the warm welcome. I will try to live up to the expectations. So yeah, I mean, I have been working in educational robotics for 18 years, 5 years as a PhD student, and then 13 years running BirdBrain Technologies and kind of continuing to develop new products in that space. And so Pam invited me to kind of give a sort of a viewpoint or a perspective of where I see trends going in the robotics and computer science space. So using robotics in computer science. Obviously, I'm a big believer in using robots as one tool to engage students in computer science. It's certainly not the only thing out there. There are a lot of other wonderful technologies. But I think, you know, that sort of hands-on kind of component of robotics is a pretty strong engagement technique. And so I wrote this talk, it's a brand new talk, and I called it 50 Years of Educational Robotics, because I realized that educational robotics had actually been around for 50 years. And so I'm going to drop the link to the slides in the chat, and I'll also share my screen so that you can follow along with them. Right. We seeing that? All good? Okay. So, so yeah, the picture on the left there is of some students using the Logo Turtle, which was a robot that was developed in the 1970s. And students could program these with the Logo programming language, which is sort of an ancestor of Scratch. And they could actually get it to draw. And then on the right, we have pictures of the newest Finch robot, which came out in 2020. And guess what? The students are programming it to draw. But a lot of other things have happened kind of along the way. And so I'll try to talk about some of those. Now, you've got a great overview of BirdBrain technologies, so I'm just going to skip right over this. You'll get to play with the Finch, which is wonderful. As I mentioned, the newest Finch came out in 2020. We think of it as one robot that can support coding and computer science education starting in kindergarten all the way up through college by supporting many different programming environments. So icon-based for young kids, blocks-based for a little bit older, and then text like Python or Java for older students. And then we briefly mentioned was the Hummingbird Robotics Kit, which is unlike the Finch, it is a kit of parts, electronics, which students use with animatronics or craft materials, cardboard, arts and crafts to build kind of anything that they can imagine. And that's used from about 4th grade, 10 or 11 years old, up through high school. So that's a little bit about us. So when I think about the full kind of sweep of educational robotics, right? And think about the really long-term trends that I've observed in the last 18 years and heard about from other people who've been around longer. One of those trends, I've just listed a few here. So robotics to physical computing. So in the beginning, you really had like the Logo Turtle and then a few other small robots like beam robots. Some were programmable, some were not. Nowadays, it isn't just a robot that is something that you can program that's hands-on. There's LED art and there's microbits, there's microcontrollers, there's science kits where you can get sensor data. There's all sorts of things that are out there, Arduinos. So it's actually in some ways better to think of what are all the programmable things that can be used in a hands-on fashion. And so it's not just robotics anymore. It's a bigger category that I call physical computing. Another thing that's interesting is I think when the Logo Turtle was invented, it was meant for elementary school students. And then in sort of the 1980s and 90s, robotics became more of a high school activity, at least in the United States. So I'm not sure necessarily how many of these trends are global versus kind of my perspective being in the US. But it was a lot of kind of high school competitions, robotics competitions, some middle school. And now I think we actually have a vast variety of robotics, right? We've got robots that are usable by 4-year-olds, 5-year-olds to introduce some computational thinking, all the way up to very advanced things that can be used at the college level. Another trend I've seen over 50 years is you go from hobbyist or after-school environments, where schools aren't really doing this in the regular school day, to in-school environments. So as the technology becomes easier, a little less expensive in some cases, it becomes possible for teachers to integrate this into the school day. And that means that you're reaching all students instead of just the ones who stay at the after-school program. So I think that's a positive trend. And then, of course, I said I was going to write expensive to inexpensive, but that's not really true. What you see instead is you started with expensive robots. You couldn't get an inexpensive one, but now you have a wide price range. So you have both fairly expensive kits still and inexpensive ones, and that's very good for access. So just some pictures of the representatives of these trends. The Logo Turtle from the 1970s. This is a 1980s Logo Turtle, but very much a robot. And then, in the late 90s, you had Lego and Lego robotics starting to come out. And that was starting to be easy enough to use that middle schoolers and then later elementary schoolers started using some of those kits. And then you have the microbit, which is a great example of both physical computing and inexpensive technology. So let's talk about more recently, right? The current trends that I'm seeing now. So one is really specifically about the microbit ecosystem and the rise of that ecosystem for computer science and computational thinking, and just for physical computing in general. Another is a rise of what I would term non-competitive robotics and physical computing activities. So for a long time, robotics education was dominated by this after-school robotics competition. This was especially true, at least in the US in the 90s, the 2000s. And now there's just a wider diversity of things you can do. I'm seeing some wonderful improvements in live and blocks coding systems that I want to share with you that are, I think, really interesting. So in terms of the programming environments that students use, they're getting just more intuitive, more and more intuitive. Definitely AI very recently. I mean, it's on everybody's minds, but there's interesting integration of AI into robotics. And then there's a lot of, I think, partially because of the pandemic, although some of this predates the pandemic, the idea of simulating a robot and seeing if you can get the same benefits out of using a simulation. So let me talk about each of those trends in a little more detail. So the microbit is, for those who don't know it, it is a $15, so fairly inexpensive microcontroller board. And just out of the box, it comes with a very nice blocks programming environment, very easy programming. It has a 5x5 LED array, so it can display like emojis. It has some buttons. It has an accelerometer, so if you shake it, it can sense that. It has a speaker and a microphone, so it can make simple sounds and respond to sound. So all of that, all of those features are, that's $15, which is great. But then what the developers of this did that was brilliant is they built on those kind of, you can see the gold plating, the connectors at the bottom, and that allows it to communicate with all sorts of other things that other people might create. And so when I saw this, pretty quickly, I decided to arrange all of our newest products around it. So the Finch robot, the Hummingbird robotics kit, the newest versions of those are built around the microbit. But other things, there's just a ton of other things. There's very inexpensive robots, robots that cost maybe $30, $40 that are built around the microbit. There's things like this gamepad kind of thing. There's LED kits, there's science kits, really just a ton of accessory products around it. So this, what's amazing about this ecosystem is, it's serviced by probably dozens of vendors. Dozens of vendors are developing new products for the microbit. But the microbit itself is designed for 8, 9, 10, 11, 12-year-olds. So it was designed with that person in mind, whereas older things that have had kind of a similar impact, like Arduino and Raspberry Pi, were not designed for such young users. Even an Arduino was not really designed for a 10-year-old. It was really originally designed to make it easier for artists and hobbyists to access electronics. So the microbit is the right tool. It is appropriate for education. So we're seeing a lot more kind of development there. So that's one thing. And then I've touched on this, but when it comes to what people think of as a robot, well, they have kind of a classic idea in mind that it's something that drives around and moves around. But really, we're seeing so many physical computing activities, right? So you can make LED art, you can make moving masterpieces. That's a video of hummingbird projects. You can, instrument bananas and make them conductive with a makey or sense their conductivity. You can make LEDs that light up and do different things. these are all possible, and in most cases, they require some level of programming. And so, you know, they are all things that are appropriate for CS students to do. So yeah, what that facilitates is, instead of having lots of activities that are competitive, that are, you know, let's have 2 robots, let's see which one is fastest or best at doing a certain task, we can still do that. It appeals to a lot of students, but we can also do, let's make a bunch of art that's programmable and interesting, and like, let's have an activity around that too, you know? So it allows us to draw in a larger audience. And so it's great to see this rise of these types of activities. Okay, so blocks coding. So with the microbit, main programming language for microbit, has blocks to text switch. So you can switch between blocks and Python, blocks and JavaScript. You can even edit your Python and JavaScript code and then switch back to blocks. So that is a great scaffold for students who are kind of at a transition point. Another thing that I've seen that is called microblocks. It works with the microbit, it works with a number of other microcontroller boards. But when you click on something, it instantly happens. But when you disconnect the USB connection, the code stays on the microbit. So your program stays loaded, stays programmed on it. And so you can very quickly, in a playful way, kind of click some blocks, see what they do, assemble them into a program, see what that does, and then disconnect it, and it's running, and it stays running. So it really allows beginners to get kind of play with the programming environment intuitively, the way you would with Scratch. And then, I mean, in terms of making it easier for younger students, the Finch comes with something called Finch blocks, but there's a number of other environments like this, which are icon-based, which don't require literacy. So they can be used by younger students, right? Kindergarten, first grade, second grade, 5, 6, 7-year-old students. So this sort of new style of kind of having a horizontal thread of blocks and making them based on using icons is also something that I'm both seeing and contributing to, I guess, with Finch. In terms of AI, we're seeing some robots now that have kind of some advanced AI sensors. So robots that can detect faces, that can recognize speech out of the box. And then we're also seeing a lot of AI lessons where you can train machine learning models to do those things and then use them in blocks coding, or mostly in blocks coding. So I've linked a couple here. ML machine is a way to use just a straightforward microbit, but train it to detect gestures. So you could like put your microbit on a wand, and you know, like in Harry Potter, different wand like patterns could do different things. With the Finch, I've linked these 3 examples. They are AI lessons for Finch and Snap, which is a blocks-based programming language. And they're ones for using your computer to detect images, speech, and pose, so 3 different things, and then having the Finch respond based on those. And so that's, you know, that's another thing that we're seeing, is just increased interest and increased use of AI. And then the next one is simulated robots, right? So both just simulated on a computer, but now that we are seeing a little bit of more like use of like virtual reality and augmented reality, you could even imagine, I don't know if anybody's done this yet, but I expect it'll happen soon. Imagine like having students with a cell phone and having them use an augmented reality app where they see a robot in the augmented reality app, a simulated robot moving around based on a program that they've written. If no one's done that yet, it's coming in the next 3 or 4 years, I'm sure of it. But you know, the advantage of simulation is that it's less expensive. In some cases, some of this software at least is free. I know with the Vex Robotics here, they do have a free trial or a free option. And it also can be useful as a way to test code before deploying on a real robot. Now, this is one place where I haven't really, BirdBrain Technologies in particular hasn't done any development, but certainly like Vex Robotics, I know Dash and Dot, so Wonder Workshop, I know they've worked on these. So yeah, that's another kind of trend that I'm seeing. And that is just about it. I think I stuck to 15 minutes or close to it, but I do have some time. If anybody has questions, I'm happy to answer them. See a couple of things in the chat also. Yeah.
Any questions, guys? Thank you, Tom. That was a lot. That was a lot of content and really pretty packaged. You know, with DEVCON Kids, the program that I lead, we use a lot of microbit. We have, as you can see, I don't know, you guys who are in Cebu, when you see the playground, you will see a lot of microbits. I think we only have, let's see, there's only one that's not a microbit. It could be the Cosmo robot, but that's a smart one because that has the facial recognition.
The integrated AI. Yeah.
Yes, and yeah, that's a really smart robot. So those are the things we have, but definitely microbit, my favorite, and my team knows that. Pam will want microbit. So, guys, do you have any questions over for Tom, please? You know he's friendly.
I don't have a question, but I just want to reaffirm what Tom was saying. Actually, I have a pinch robot for my classes and a bunch of microbits, and it's really, really, really cool. I'm in Los Angeles, you know, I teach robotics and computer programming, only female students. I was actually telling Pam before we started. And it's really amazing when you provide the right tools and the right path for women, with all due respect. They can be really, you know, intelligent, because, you know, usually men would think like, oh, we know everything, and that's not right. Without women, we won't be here, first of all. And but you know, the technology, the integration that you guys did with the pinch is really cool. It's really simple, but at the same time, it's very powerful for them to understand concepts like engineering, mechanics, electronics, and of course, computer science. And we actually did a little competition, internal competition, and they discovered that they can draw, you know, with the robot and talk to it. And it's really, really, really simple, but at the same time, it's very powerful. So thank you, Tom, for having this presentation.
Yeah, thank you.
Thank you, Dr. Pinto. Anybody from Cebu? Yes, I see. Oh yeah, clap hands. Cebu, any questions for Tom?
I think
or
they want to get
anybody on the call?
hands-on.
Yeah, I know. They're ready to get going. Good thing I had some.
Yeah, thank you very much, Tom, for the presentation. It was very enlightening. Just for maybe for clarification, what would you recommend with regard to the progression of learning robotics from kinder up to grade 12? Because one of the things that we want to try to level up is also with regard to our robotics program. As what you did mention, we already have it in school. It's already integrated in our program for grades 4 to grade 6. And then, if for example we also want to try to move it forward, how would we be able to try to move it forward? And what would be your recommendations if, for example, we want to try to really lay it across K to 12? Thank you, Tom.
Yeah, that's a good question. I mean, when it comes to the Finch, we almost thought of the programming language progression as that kind of, how do you take it from K to 12 with one product? But I mean, I think there's also an argument to be made for using multiple different products at different grade levels. But in kindergarten, first, second grade, you know, you can explore our Finch Blocks app, and basically what you want to be doing is, at least from a computer science perspective, explaining to kids computational thinking concepts, or having them practice computational thinking concepts with a simple icon-based programming language that allows them to learn things like an algorithm is a sequence of steps, or what is a loop, or you can actually introduce those types of things very, very young, 5, 6, 7 years old, before they're really fluent at reading even. So that would be my recommendation for the really young kids. And you can mostly stick to things that just use outputs, so that don't use sensing yet. Once you get into sensing, you get into conditionals, variables. Some of those concepts might be, especially at the kindergarten, first grade level, might be too much. But you can do things like have the robot draw shapes, have the robot light up and dance, those kinds of programs. And I mean, I'm talking about it with respect to the Finch, but there are other robots that can do similar things at that grade level, kind of. So I think that's sort of the activities. And really your goal, your learning goal isn't, it is those computational thinking concepts, right? It is, what is an algorithm? What is debugging even, things like that. That sets them up well. And then, yeah, at the upper elementary, 4th grade, 5th grade, 6th grade, you can do blocks-based coding with them using sensors. I think that's very important, is showing them what a sensor is and how to use it, how to use an if-else statement, how to use a variable, how to use some math to scale the sensor to a range that you might want to use for a different program. And then you can even, in some of these blocks environments, start talking about modularity, right? So talking about like a function or a block that you make that's a custom thing that you just made. So, and why you would want to do that, right? Why, like, you want your code to be modular. And that, yeah, I think there's lessons there up through 8th grade. I think at this point, if you've been doing that for a while, you can probably introduce some artificial intelligence lessons at the 7th or 8th grade level using machine learning models that they train. So not necessarily getting into the very detailed, like, technical explanation of it, but using it to train a model, and then that model becomes a sensor that they use to control the robot. It's essentially a new sensor. So that's something that that's newish, but I would be doing that at the middle school level now. And then, yeah, at the high school level, of course, you start them on text coding, Python. Python is the language I think is the best to start with. Java is still popular in the United States, but that's because of an AP computer science, a college computer science class and exam. I think Python is much more valuable and easier to start with. So yeah, that's sort of a progression. And like I said, there are, the Finch could work at all of those levels. There's other robots out there that can work at some of those different levels. And then I guess the last thing I would say is, I've been talking about this from the perspective of how to use robotics to support computer science education, but that's not the only thing you might use robotics for, right? Engineering education, engineering design, even creative project-based learning, those are other things that you can use to support it. And so, at the high school level, maybe you're 3D printing, or you're having them do some CAD design and building a robot, right? Like that kind of thing. At the middle school level, maybe you're having them build out of cardboard, but they're still building something complicated. Yeah.
How about, thank you very much, Tom, for the answer. But how about also with regard to Internet of Things? How early can we introduce IoT to the kids?
I didn't quite hear that. How early can you introduce Internet of Things?
Yes.
Oh, okay. Ooh, that's a good question. Okay, so there's a platform out there that's sort of academic that's called NetsBlocks. Academic in that it is a university research project, but you should look it up. So NETSBLOX. And it is a blocks-based programming language with networking. So it's not quite IoT, but the kids can create things like multiplayer Scratch-like games, like a Pong with 2 players that are remote, So that's a pretty cool kind of introduction. Plus, they have a number of libraries where they scrape data from Internet of Things devices, right? So from sensors, from things like the seismometers all over the world, weather stations all over the world. So I think that's a nice way to introduce that is free. It's a free environment. Yeah.
This one, Tom?
Yeah, that's it. And then, so that can get you some of the concepts. And I'd say 7th, 8th grade again, especially if they have all the background of block-based coding already, right? So you wouldn't want to make that the first thing you do with block-based coding. But once they have some of those concepts down, I think you can use it. And then there's lots of physical computing style kits that are Internet of Things devices, right? That you could buy something that reports out over the internet some data and then uses that. That's more of a high school activity, probably.
Yeah, we were just looking at the Arduino one, and they have an IoT kit that you buy on top of their regular kit, but you also have to get their monthly service per student. So that makes it expensive.
Yeah, that's the trick with IoT. Especially if it's like a cell phone connection or using a cell phone data, then it's going to cost money.
Right.
Yeah, or a cloud connection. They have to pay for the cloud server.
Yeah, that's the cloud service. Yeah, that's what they called it.
Yeah.
Sir Michael, thank you. Any more questions from our teacher attendees in Cebu?
Any other questions? No. Very interesting. They're
Yes?
already planning, madam.
They're already planning?
Yeah.
There you go, Mike. Tom.
Great.
All right. How many finches are being bought now? I've always wanted a hummingbird. And guys, I don't know, you don't ship internationally, right, Tom?
We do ship internationally, but what we really need is a reseller network, because it's difficult. You know, when you ship internationally, it goes through customs. And so often whoever is buying it doesn't know that there will be an additional charge depending on the country. It can be anything from nothing to 25% is normal. And then in Brazil, it's like 100%. So international shipping, we do offer it, but it is expensive, and it's always better if we can find a reseller. So if you know of resellers, right?
Can we apply for
We'd
one?
like to be one.
Yeah, I think you're talking with Jenna already, so that could help.
Okay, CSTA Philippines. I actually asked. Yeah, I'm in contact with somebody in Tom's team. Hopefully we can proceed with that. Okay, anybody online who has questions for Tom? I know he's been gracious about staying for questions, and I appreciate it very much. Mom Jess, Mom Sir Edwin, Sir Joel, any questions? Will the recording be available? Yes, we will make it available on our Facebook, and we can get it on our webpage as well. With your permission, Tom.
Oh, of course.
Yeah,
Absolutely.
it's okay. All right. Oh, any other questions, guys, before we say goodbye and good night to Tom?
All right,
photo? Oh wait, I'm getting down, scrolling. Thanks. That's it.
All right.
Thank you so much.
Raising
Have
up
a good morning,
Really
everybody. Enjoy your playground. Enjoy playing around.
Thank you, Tom.
Bye.
Bye. God bless.
Thank you, Tom.
Thank you so much. Appreciate you.
Thank you.
Okay, thank you. For all of us on the call, we are going to, I don't know, Sir Mike, do you want us to hang around for a few minutes and then we can say goodbye so we can watch you do your stuff?
Yeah, sure. Thank you very much for facilitating Ma'am Pam with Tom. with the meetup with Tom. And maybe we'll just try to have a short break. I think the snacks will be coming over soon. So maybe we can try to resume by 10 o'clock. So by 10 o'clock, we will proceed with the playground. Can you still stay, or it's already nighttime? It's already nighttime in your area, right?
Yeah, I don't think I'll stay, but I know that the team is there. So yeah, and good luck and have fun, please.
Yeah, we
Yan,
will.
yan.
be trying
Hi,
out,
I see you, Mr. President. Miss President of Cebu, DEVCON, by the way, is in the house.
Thank you.
Who was that who was dancing? Cebu DEVCON is here. Okay, so we will say goodbye then. Sir Michael, thank you so much for arranging this. I think it's so cool that we did this today.
Yeah,
Thank you.
it's good that we
Okay.
pushed through.
Yes, indeed. Okay, guys. Thank
Okay.
you. I'm going to say goodbye and
Okay.
have fun, guys. Thank you so much.
Okay, God bless. Thank you. Take
Bye.
care. Bye.
Bye, everyone.